Hi, this is Tim Malloy with Video4-2. This one isn't that bad, so maybe I can run through it real quick. I'll be doing problem number 8. The pens didn't think it won't work again. Okay, so two parallel rails with negligible resistance are 15 centimeters apart and are connected by a resistor R3 equals 5 ohms. The circuit also contains two metal rods having resistances R1 equals 14 ohms and R2 equals 15 ohms, sliding along the rails, like away from the center. And the rods are pulled away from the resistor at constant speeds of V1 equals 4 meters per second and V2 equals 2 meters per second, respectively. We have a uniform magnetic field of 0.01 teslas is applied perpendicular to the plane of the rails, determine the current in R3. Yeah, I was just circling things as I went along, just so this picture kind of made sense, and I think it's pretty simple picture, I guess. Okay, so and they want the current in R3, they want magnitude and direction. So first off, I wish I did this thing for the quiz because popped up on the quiz, and I think I did okay on it, but would have been nice to have this practice. Can't argue with that. So as the bars travel outwards, which they do, then the magnetic flux increases because there is more area covered by the magnetic field. Yeah, okay. So if we apply Lenz's law, again, field is in flux is increasing. We need flux to oppose this increasing flux. So where a magnetic field is in the opposite direction, originally it's into page, now it's out of page. And since we know flux is out of page, we can determine that the path of the outer loop of the current will be counterclockwise. So that's cool and all, we know the direction of current, but where are our EMF sources? The key is in the moving bars, because we have the formula electric potential equals, what is this? Magnetic field times length. So that's going to be length between the rails in this problem, and then times the velocity. So from this velocity, we are going to have voltage. So for each of the bars, I plugged everything in the formula. Pretty simple. We get 0.006 voltage for V1, and then we get half of that for V2 because it's velocity's magnitude is half. Okay, so now we can make a new circuit. So just hang with me. Um, so I kind of split the metal bars into two parts, just no real, just for understanding's sake. So here's our bar 1 with its voltage source and resistance. Here's our bar 2 with its voltage source, or our bar 1 with its voltage source and resistance. Again, we know that the outer loop's current direction is counterclockwise. And then, so that's everything on the outside covered. And then we have our R3 resistance in the middle. And we don't know which direction I3 is headed in. So we'll say up for now, and if we get a negative answer for our current, then we need to flip it to downwards direction. Okay. So then I did my loop rules, starting with the outer loop, and let's travel clockwise at this A point. So we have plus V1, and then minus R1. Wait, did I do this? Give me a second. Oh, I did. I just mislabeled a couple things. Okay, it's okay. So yeah, our voltage 1, and then minus resistance times. That's where I messed it up. Okay, so uh, add voltage 1, and then subtract R1 times I1, and then add your voltage 2, and then subtract 15. Subtract R2 times I2. set equals 0. Okay, so that's our outer loop. And then for our leftmost loop, we have adding our V1, subtracting our R1 times I1, and then we're going to go up into the center here, and we're going to subtract our 5, we're going to subtract our R3 times I3. Okay. And then we also have the junction rule, which states that I2 plus I3 equals I1. Okay. Yeah, sorry I had to correct the currents there, but everything was consistent. My naming was just off is all. And then what we're going to do is we're going to plug in for I1. We're going to go back to the our two equations, which is these top ones. And then for I1, we're going to plug in I2 plus I3. Really simple because then it's just a system with two variables. I3 equals 1.35 times 10 to the negative fourth amps. Put that in terms of microamps, we get 135. Current was not negative, so we can keep that upward direction. Okay, and that is correct. I checked on the website. So takeaways is, okay, maybe quiz wasn't that bad, but wish I kind of understood to place the voltage sources on the circuits when I did the quiz. Also, that junction rule is a big time saver. Just really easy to go from three equation, three variable system to a two equation, two variable system, which is much easier to solve. And I mean, even if, going back to this, if you get lost like me and you start calling things like the wrong things, maybe, as long as you're consistent with your inconsistency, you'll figure it out. They should put that in a book.